In this problem, we're asked to find the solutions of the equation cosine theta is equal to 1 over secant. We will recognize that this is our reciprocal identity, that cosine of theta is equal to 1 over secant theta. And we want to know for what values of theta this will hold. Well, we would know that it holds for all values of theta because of the reciprocal nature, except when the denominator takes on a value of 0. Therefore, we're looking for places where the secant of theta is equal to 0. Secant of theta is equal to 0 or has asymptotes at pi over 2 plus every n pi for any integer n. We will know this because we can find the values where the cosine theta takes on a value of 0. And that happens at every odd multiple of pi over 2, which gets us to the equation again. In our next problem, we are asked to find the solutions of the equation 2 cosine 2 theta minus the square root of 3. We will recognize in this equation that the period of our function is 2 pi over 2, or pi units. In order to solve this, we will isolate cosine of 2 theta. Therefore, we'll have the cosine of 2 theta is equal to the square root of 3 over 2. If we looked in the interval for 0 to 2 pi and let 2 theta be equal to x, then looking at cosine of x is equal to the square root of 3 over 2, we could find the two specific solutions to the cosine of x equaling the square root of 3 over 2. We would recognize this would be in a quadrant 1 and quadrant 4 angle, where x would be equal to pi over 6, or x will be equal to 11 pi over 6, plus the period of the cosine of x. But really we wanted 2 theta, not x, to be equal to these general solutions. So we want 2 theta to be equal to pi over 6 plus 2n pi. That gives us theta is equal to pi over 12 plus n pi, dividing both terms by 2. Notice we are getting our period of our original function. We also want 2 theta to be 11 pi over 6 plus 2n pi, again dividing everything by 2. I'm going to get 11 pi over 12 plus n pi. Suppose we wanted to list all the solutions in the interval from 0 to 2 pi for our function, for our values of 2 cosine 2 theta minus square root of 3. We would recognize that we would have cases where n is 0 and n is equal to 1. When n is 0, our first one gives us pi over 12. Our second one gives us 11 pi over 12. When n is equal to 1, we have pi over 6 plus 2 pi, or pi over 6 plus 12 pi over 6, giving us 13 pi over 6. Excuse me. Would give us, looked at the wrong one, would give us 13 pi over 12 when n is equal to 1. And looking at the second one, when n is equal to 1, we're going to have 23 pi over 12 as our four solutions in 0 to 2 pi.